Welcome to Lesson 65. Today we're diving deep into async commands and background tasks in Tauri. This is a crucial topic for building responsive desktop apps. Without async, long operations would freeze your entire UI. Before we begin, make sure you have Rust and Node.js installed. You should also be familiar with basic Tauri commands from earlier lessons. We'll build a file processor that simulates a long task while showing real-time progress to the user. Let's start by creating a new Tauri project. I'll copy our base template to create a fresh project called Async Demo. This gives us a clean React plus TypeScript frontend with the Tauri backend already configured. The base template includes all the necessary dependencies, so we can focus on writing the async code. Now let's navigate into the project and take a look at the structure before we make our changes. We'll be primarily editing two files, lib.rs in the Rust backend, and app.tsx in the React frontend. Before we write code, let's understand what async means in Tauri. When you mark a Tauri command with async, it runs on a separate thread managed by Tokio, which is Rust's async runtime. This means your long-running operations won't block the main thread, keeping your UI responsive. The key difference from regular commands is the async keyword before fn, and we can use .await inside the function. Tauri's command system automatically handles the threading for us. We just need to write our async logic. For progress updates, we'll emit events from Rust to React. This creates a real-time communication channel. Let's open lib.rs and start building our async command. First, we need to add the necessary imports. We import serialize for our progress payload structure. This lets us send structured data from Rust to JavaScript. We also import duration from stdtime. This will help us simulate a long-running task by adding delays. Now let's define our progress payload struct. This is the data we'll send with each progress update. The struct has three fields: progress as a U32 for the percentage, message as a string, and is underscore complete as a boolean. Notice the derived macros, clone and serialize. Clone lets us copy the struct, and serialize converts it to JSON for the front end. This pattern of defining a payload struct is very common in Tauri when sending events to the front end. Now for the main event, our async command. Notice we use async fn instead of just fn. The function takes app_handle as a parameter. This gives us access to Tauri's event system so we can emit progress updates. We also take total_steps as a U32. This represents how many steps our simulated task will have. The return type is result with string for success and string for error. This pattern lets the front end know if something went wrong. Inside the function, we create a for loop from 1 to total_steps plus 1. Each iteration represents one step of work. Here's the key async part: Tokio time sleep with await. This pauses for 100 milliseconds without blocking the thread. In a real app, this is where you do actual work like processing files, making API calls, or computing data. We calculate the progress percentage by dividing current step by total steps and multiplying by 100. Then we emit the progress event with our payload. The front end will receive this and update the progress bar. Finally, we return OK with a completion message. The front end receives this when the entire task finishes. Don't forget to register our new command with Tauri. This is a step many beginners miss. In the run function, we add process task to the invoke handler macro. Without this, the frontend can't call our command. The invoke handler tells Tauri which Rust functions are exposed as commands to the frontend. Now our Rust backend is complete. Let's move to the React frontend to display the progress. Now let's build the React frontend. Open app.tsx and we'll start fresh with our imports. We import useState and useEffect from React. These hooks will manage our progress state and event listeners. From Tauri API, we import invoke to call our async command and listen to receive progress events. We define a TypeScript interface for our progress payload. This matches the Rust struct we created earlier. Type safety between Rust and TypeScript is one of Tauri's strengths. It helps catch errors at compile time. Inside our app component, we set up 3 pieces of state: progress as a number, message as a string, and isProcessing as a boolean. isProcessing will control whether the start button is disabled while a task is running. Now we set up the event listener using useEffect. This subscribes to progress events from Rust. The listen function is async, so we create an async setup function inside useEffect and call it immediately. We listen for the task progress event. This matches the event name we used in our Rust emit call. When an event arrives, we extract the payload and update our React state with setProgress and setMessage. If is_complete is true, we also set isProcessing to false to re-enable the start button. The listen function returns an unlistened function. We store this and call it in useEffect's cleanup. This cleanup prevents memory leaks when the component unmounts. Always clean up event listeners. The empty dependency array means this effect runs once when the component mounts. Now let's create the start task function that triggers our async Rust command. We set isProcessing to true and reset progress to 0 before starting. This gives visual feedback immediately. We use invoke to call process_task, passing total_steps as 20. This means our task will have 20 steps. Invoke returns a promise that resolves when the Rust function returns. We handle both success and error cases. Now for the JSX. We create a container div with Tailwind classes for styling. The heading displays async task demo. Below that, we show the current progress percentage and message. For the progress bar, we use a simple div with a colored background. The width is set dynamically using the progress state. The inline style uses a template literal to convert progress to a percentage width. As progress increases, the bar grows. Finally, the Start button calls Start Task when clicked. It's disabled when his processing is true. We change the button text and style when processing to give clear feedback that something is happening. Let's see our async task demo in action. I'll click the Start Processing button. Watch how the progress bar fills up smoothly. Each step updates in real time from our Rust backend. Notice the UI remains completely responsive. We can resize the window and everything stays smooth. The message updates with each step, showing exactly where we are in the process. And there it is. Task complete. The button is re-enabled and we can run it again. Let me run it one more time so you can see the full cycle from start to finish. This pattern is perfect for file downloads, image processing, data imports, or any long-running operation. Let's recap what we learned. First, async commands in Tauri use the async keyword and run on Tokio's thread pool. Second, we emit events from Rust to react for real-time progress updates. This keeps users informed. Third, always use Tokio time sleep with a wait for delays. Never use std thread sleep in async code. In the next lesson, we'll explore proper error handling in Rust. Thanks for watching.